You go, well, that's a spectrum. That's the information to a chemist. And if a teacher can't use the colors of the rainbow to make something artistic out of something so dull and mundane and black and white and one-dimensional, then something ain't right. This is our periodic table by solar system abundance. So if we look at our solar system now, and you can overlay these. This is what's great now. Okay, we got the abundances of the elements for the solar system. So lots of helium again, lots of hydrogen again, lots of silicon again. What do you think of that, huh? Silicon dioxide is sand. Carbon dioxide is the photosynthesis. Notice they're in the same family there. Oxygen, sulfur's underneath that. Lots of sulfur, lots of oxygen. Lots of nitrogen, huh? So again, you don't have to look at the numbers. You don't have to comprehend anything. Anybody can look at this and just see the size. The solar system. Iron, lots of iron in the solar system. What about, say, cobalt, manganese? Look at magnesium. Lots of magnesium in the solar system. Calcium. So what's fun to do is look at this and start thinking, well, wait, some of these elements are essential to humans. So if it's essential, like iron, look how much iron there is. Is that a coincidence? The elements that are essential seem to be really abundant. So it makes me wonder, there has to be a grand design, because if we needed a lot of iron to live and there wasn't a lot of iron, it'd be kind of tough to live, huh? Well, hemoglobin, a lot of your enzymes when you're breaking down sugars to get ATP in the mitochondrion, iron is used. So again, doesn't this just look cool? Get rid of me. Look at the fun stuff. You've got all kinds of sun and planets and asteroids, meteorites. Here again is a real awkward position. The touchpad can tell if it's your pinky or your thumb. It only does it for your forefinger. So excuse me, but I got to move all this crap out of the way just to get to this, and then it knows when it's my index finger. Is that just? This is dumb. Come on, Illustrator. You're supposed to be a graphic arts program for the professional, and you're acting like something from. I won't even insult the flea market or thrift store because you were just not. God, this is like the dumbest thing I've seen in a long time. So anyway, down the bottom here, we'll just look at the bottom since we can't get the top on here. This is idiotic. People, this is why you need to be educated. One, to comprehend the stupidity in the world. Second, I hope you can change it. I want the world to be better for you kids. The elements here, now look down. Chromium, manganese, so all the first row of metals, all in there, all kind of evenly dispersed, right? Iron, if you remember, binding energy curve peak, so iron's right at the top. Cobalt, nickel, those were the three I said that the stars make. But right beyond that, copper, zinc, look at all pretty much in even proportions. This is the solar system again, right? So copper, zinc, these are used in the enzymes in the human body. Blue, not so much here. See the next row of metals coming through here now? So we just look. Red is the most abundant. Orange, yellow. Then you get to the greens. By the time you get to the blue, there's not much, but there's some platinum in the world, in the solar system. Then you start noticing what I started throwing in was the balls where there's none. So it's easy to look at. Put a little bit of cool stuff behind it. Fun to look at. Fun, and you learn. It's a no-brainer. There's the periodic table with the elements of the Earth's crust. So this I thought was pretty neat. Just look at the Earth, okay? And the solar system, okay, that's solar system. But Earth, this is where we live. What's the Earth? The land. That's what the crust is. Oxygen. What's oxygen? Like a penguin walking through here. Oxygen, silicon. Silicon dioxide. Is there a lot of sand on the Earth? Quartz. Silicon dioxide. Look at the two most abundant elements on the crust formed together. Coincidence again? I mean, that's a grand design. If there's lots of silicon around, do you want it bonding with manganese or with sodium? No, it bonds covalently with oxygen. This always surprised me. There's a lot of aluminum. Lots of aluminum in the crust of the Earth. It's really hard to separate. You know, the top of the Washington Monument is capped in aluminum because at the time that was one of the most expensive metals that there was. To separate it took lots of energy, which now is done routinely, cheaply. So aluminum is not as sought a metal as it once was for making crowns for kings and stuff. Could you imagine every homeless bum on the corner's got a crown made out of aluminum, but if you had that in the 1830s, aluminum was worth more than gold. So, chemistry. Elements of the Earth. The crust has just about everything there, doesn't it? So when you look at the periodic table now, you can look and go, hey, lots of lead, because we see red down there in the green and the blues. What's the last, like, real abundant element? You look back and you see red, well, you see barium. Come back across this way, no reds. So when you get to niobium, I never would have thought there's that much niobium in the world. Molybdenum. Tungsten, look at there. Yellow, not a lot, but there's some. Just look more official. Get the cow hat on, better make it look good. So anyway, periodic table of the Earth's abundances. This I thought was pretty cool, just to this shows the abundance of the elements in the Earth's oceans. In the oceans, what do you think of that? Look in the ocean, lots of oxygen, lots of hydrogen. Gee, again, if you got lots of oxygen and lots of hydrogen, why not make those two bond together? H2O. So what's dissolved? See, this stuff to be in the ocean's water has to be dissolved, right? So you got a lot of sodium. Sea salt is going to be more than just sodium chloride. You're going to have magnesium, calcium chlorides, fluorides. There's fluorine. These are all written on the periodic table as elements, but a lot of them are going to be ionized. They pretty much have to be ionized, other than things like C for the CO2, which would be dissolved. Carbonic acid, they call it. Silicon. Chlorine, look at that. Lots of chlorine in the salt water. Sodium in the salt water. Calcium, potassium, magnesium. These four right in a row. Salts. When you talk about salts, it's not just sodium chloride. You're going to have magnesium, calcium, K for kalium, which is potassium.